So let's start with the first problem. So you have to calculate the value of the integral of the form integral 0 to 6 3x square dx by dividing the interval 0 to 6. You have to cut this interval into 6 equal parts and you have to use Simpson's 1/3 rule for solving the integral. Actually, you can solve this integral easily and get the answer, but since it is first problem, I'll take a simple one here. So first of all, when the problem is given, the first thing which we do is we try to rewrite and we try to get the value of y from the integral. So we already know that in case of numerical integration, we write the integral in the form integral a to b y dx. So which is that integral here? That integral here is integral 0 to 6 3x square dx. So from that you can guess what's the value of y. So the value of y here is nothing but 3x square. Then let's see what else do we need. For using Simpson's 1/3 rule here, what we need is different values of y in this interval, and you also need to know what is the value of step length h. So how do you calculate the value of step length h? H is equal to b minus a divided by n. You already know what is b in this case. B is nothing but the upper limit of the given integral. The upper limit of the given integral here is 6, and a here is nothing but the lower limit of the given integral. So what should be b minus a? It should be 6 minus 0. 6 minus 0 is nothing but 6 divided by n. N is nothing but the number of equal parts of the interval given here. So n here is clearly given to you in the question, that is 6. So 6 by 6, the value of step length or width or h is nothing but 1. So after getting the value of h also, we can make the required table. So the first value here is nothing but the values of x, and the next value is nothing but the corresponding values of y. We already know what is y in this. Y is nothing but 3x square. So let's write down the values. I have told you how do you write the values of x here. So we start with the lower limit of x, which is the lower limit of x here, that is 0. And the last value taken by x should be the upper limit of x, which is nothing but 6. So how do you fill up the in between values in this? By using the step length. The step length here is 1. So if you want to get the next value here, take the previous value, add it with the step length. So 0 plus 1. So the next value here is 1. Next value is obtained by adding 1 with step length. So 1 plus 1, which is 2. Next value should be 3. Then you have 4. And the next value here will be 5. Once this is done, we have to get the values of y. So these values of y are called as y0, since it is the first value of y. Then you have y1, y2, y3, y4, y5 and y6. So let's see the values. So when x is equal to 0, what should be the value of y? 3 into 0 square, which should be 0. Next value should be 3 into 1, 3. Similarly, you can get the next value 3 into 2 square, that is 3 into 4. So you get 12. Then you have 27, 48, 75. And the last value here is 108. So I will just call them so that you can easily get these values while you are applying the formula. So they are called as y0, y1, y2, y3, y4, y5 and y6. This problem is simple, but in case of some complicated problems, what we can do here is we can save the function here in your calculator and just go on putting different values of x so that you can get the answers of these terms easily. So you can save this function as 3x square in your calculator, and by using CALC button, that is calculate button, putting by putting different values of x, you will get the required values of y. So let's see. So here we are using Simpson's 1/3 rule. So first let's write that rule here. I is equal to, that is the value of the given integral, is equal to, which is given integral here, that is integral 0 to 6 3x square dx. You are using Simpson's 1/3 rule, so h should be multiplied by 1 by 3. So the formula says h by 3 into y naught plus yn. So while writing the formula here, what we can do is we can write the general formula and then use it for the given case, or you can directly write the formula which we need to solve this particular problem. So I'll directly start with the formula here. So what we do is, please listen to this step carefully. So what we do is we take the first term as the sum of the first value of y with the last value of y. So which is the first value of y here, that is y naught, and the last value taken by y here is y6. So we write y naught plus y6 plus the next term here is 4 into, here we write all the even subscripts of, we take all the odd subscripts of y. So the odd subscripts of y terms are, you have y1 here, then you have y3, and then you have y5. So we write y1 plus y3 plus y5 plus the next term here is 2 into. Now what do we do is we take all those terms which have got even subscripts for y here. So please note, you have already taken y0 and y6 for the computation purpose, and they are already listed out here. So when you are writing the even subscript terms here, please do not consider the first term and the last term because they are already here. So which are the remaining terms of y which has got even subscripts, that is y2, and the other term is y4. So you have y2 here and you have y4. I'll just explain this once again so that you can understand it properly. So you have been given that you have to use Simpson's 1/3 rule. So the step length h will be multiplied by 1 by 3. And while writing the formula here, the first term is always nothing but the sum of the first term with the last term. So the first term of, or the first value of y here is y0, which is added with the last value of y, which is y6, plus 4 into, take all those terms of y which have got odd subscripts here, and those terms are y1, then you have y3, and then you have y5. Once they are done, plus 2 into, here we take all the terms of y which have got even subscripts. But please note, in that case we do not consider y0 and y6 because they have already been considered over here. So we take only those terms of y which have got even subscripts which are remaining now, that is y2 here, and other term here is y4. So in the next step, what we do is we just put the value which are given. H is already calculated, which is 1 by 3. Then you have y0 plus y6. Y0 here is 0, which is added with 108. So it's nothing but 108 plus 4 into y1. Y1 is here 3, which is added with y3. So 3 plus 27, which will be 30. 30 plus y5, that is 75. So 30 plus 75, which is nothing but 105 plus 2 into y2 plus y4. Y2 is here 12 plus y4, which is 48. 48 plus 12 will be 60. You need not write all these steps. You can directly substitute and calculate the value. Simplify, you get the answer as 216. In case of this problem, you can actually solve this integral by using the usual method which you know already and get the answer. And you can check whether the answer which you have got by using Simpson's 1/3 rule and verify your answer. So here if you solve this integral by using the actual method, integral 0 to 6 3x square dx, you get the answer as 3 into integration of x square is x cube by 3. Put the limits for x which are from 0 to 6 here. Cancel this 3 and 3. X cube, that means 6 cube here minus 0 cube. 6 cube will be nothing but 216. So you can see that here the actual value is matching with the calculated value, but need not be the same in case of the remaining problems.